Hi, my name is Sudipta Majumdar, and I'll be presenting a paper that was presented in the ASEAN conference on cloud computing in the year 2020. The paper is titled SNF Serverless Network Functions, that was authored by Arjun Singhvi, Junaid Khalid, Aditya Kela, and Sujata Banerjee. So, as technology is progressing day by day, cloud is becoming more and more important for us. While outsourcing network functions to cloud is becoming more common with that, network services currently do not provide us with any network function as a service or NFAAS to deploy custom built network functions to cloud. If anything we want to deploy uses the existing framework, it will be fine, but anything beyond that is currently not supported. Also, as we know that current technology is going using serverless networks, that serverless network has two limitations. One, coupling of billing and work assignment granularities, and two, state sharing via external store. So the authors in this paper have proposed a method called an SNF that aims to solve both these problems. So, coming to the solution, SNF is basically a serverless NFAS or NFAAS platform. The architecture basically comprises of two parts, the controller and the NF runtime. So, as we know that information currently travels in the network in the form of packets. So, once these packets arrive at the controller is going to take it up, move it to the compute unit where the function is executed, and get it processed. So this controller consists of three main parts: the workload granularization module or the WGM, the work assignment module or the WAM, and the state management module or the SMM. So what will happen is when packets from different flow arrive at the controller, the WGM is going to granularize the incoming flow into flowlets. Once it has been granularized, it's going to determine which flowlet it belongs to. If it belongs to an existing flowlet, then it is routed to the appropriate compute unit. If not, then that flowlet goes to the next module or the work assignment module, where it determines the appropriate compute unit to which the new flowlet should be assigned. So this basically means when the packets are part of an existing information chain, then it will be granularized and moved forward. But once we encounter a new packet for some new information, then from WGM it's going to WAM and then further. Next up, we have the SMM or the state management module, which is going to encode a small amount of metadata to each packet, which compute units are going to use to push or pull state to and from and logical clock to prevent status state updates. Next up, we have the NF runtime. So NF runtime is a network function runtime which realizes the notion of ephemeral stateful functions, and it is responsible for state management at each compute unit. It's going to handle all the updates and transfers among different compute units in a peer-to-peer manner. And this state management is done transparently. And given that these packet arrivals in events are done in a familiar model, the process packet routine is called whenever a packet arrives. So as we know that this approach is quite novel as it is completely new, and the authors have made it novel, and we can also conclude that for the following reasons. First, billing and programming at per packet granularity. Having events as packet arrivals where it has been broken down into each packets and then into flowlets gives it an ideal billing condition. Work assignment at per flowlet granularity. As we have already discussed that the information is broken down into flowlets, which helps into making decisions at a very granular level instead of the current method where the entire flow is taken and then we do the assignment. Next up we have the peer-to-peer in-memory state storage, which makes the system much more faster. The system has a high fault tolerance, and also it eschews complete statelessness and adopts ephemerally stateful functions. Coming to the critique area. So as we have already seen that what the NFAS methodology is being used here for doing the SNF, for creating the SNF, where the basic flow is like it will have a packet processing workload which are gradually granularized into flowlets. Then the NF internal state is stored in the local compute unit where a given flowlet is being processed. And to achieve efficiency, the authors have proposed a new algorithm called the weighted greedy bin packing algorithm. This will maximize packed flowlets into a few compute units and ensures all performance targets are met. This particular approach has been tested by the authors using 30 Cloud Lab servers, each with 20-core Intel Skylake CPUs and a dual-port 10G NIC. The bandwidth is 1 Gbps and the timeout is kept at 500 microseconds. And this is compared against the current baselines, reactive state and optimized external state. Against both, the SNF has performed remarkably well. While this does solve a lot of problems, we still have a few issues that remain. Some of them being bumpy service, computationally expensive, and management exhaustive. Since we've already seen what can be the drawbacks, I would suggest working on those as scope for improvement. So for bumpy service, I would propose that we need to do resource utilization in a more proper manner. As we know that when the load is high, we are allocating more resources while at other times the resources are kept very low. Well, this makes sense when unfortunately when we have very less packets available, less resources available during off times. It's not the information is not granularized properly, which makes the service bursty. This needs to be resolved by allocating the resources in a much more linear way. Cost effectiveness, uh, since we are spending a lot more time on the network, it increases the cost to the user. This has to be reduced to make it more profitable and user friendly. And thirdly, the life cycle needs to be compressed to reduce the management time. Finally, this is the schematic diagram of the SNF architecture. As we can see that this is the controller which has the work granularization module, the work assignment module, and the state management module. Once it is done, it then goes through the NF runtime. With this, I will conclude my presentation. Thank you so much.